Today we are going to discuss about the periodicity of properties, that how properties change with the regular interval of a time. Today we are going to discuss first property, that is atomic size and atomic radius. What is atomic size or atomic radius? Half of the distance between the nuclei of the two bonded atoms is referred as the atomic radius of the atom. Here you can see the two atoms of hydrogen. It is very difficult to calculate, to measure the radius of one atom, because we know that atom is very small, and due to that very small size we don't have definite boundaries that fix their size, and we are not able to calculate the radius of the atom. So that's why we take two atoms and we assume that these two atoms are attached together from their boundaries, and we are going to take the radius of these two atoms. From the center to the circumference, this distance is radius, as we know that. The distance from the center to the circumference from any point. The distance from center to this point, for distance from center to this point, is considered as the radius. So that is very difficult to calculate the radius of one atom. So we take two atoms and take the half of the distance of the two nuclei from their center. This is one atom center, this is the center of the another atom. This is the distance between the centers of the two atoms. We are going to calculate this distance of these two atoms. For example, this distance is approximately, for example, 160 pm. Then what will be the half of the distance? So if you divide this 160 with the 2, you know that what will be the half of the distance. If we take the example of your book, the atoms of 2 carbon, here, the 2 atoms of carbon, distance from the centers of their atoms, for example, is equals to 154 pm. This is the radius for one atom and this is the radius for another atom. The total is 2r. So this value is 2r. Two atoms radius for this atom and the radius of this atom. The total distance between the centers of the two atoms. This is 154 pm. If I want to know about the radius of the one atom, so I have to take the half of this radius. So half of 154 is 77 pm. So this is the radius of one carbon atom. Due to the very small size, it is very difficult to calculate the radius of the one atom. So we join two atoms and take this radius of both. The distance between from their centers, we calculate the distance from their centers, that is 2r, and we want to know the radius of the one atom. So the radius of one atom is the half of the 2r. This is the value of the radius of both the atoms. If we are going to take the half of this value, we will get 77. This 77 is basically the radius of one atom. 77 plus 77. So according to the main statement, here you can see half of the distance between the nuclei of the two bonded atom. If there are two bonded atoms, you are taking half of the distance, then that distance is called as the atomic radius. Because it is difficult to take the radius of one atom, we calculate the value of radius by joining two atoms. The next important thing After knowing the basic definition, the basic statement about what is atomic size or atomic radius is that in a periodic table, which element having a high atomic radius or a high atomic size, and which element having a lower atomic radius or lower atomic size. Here you can see the structure of atom. Electrons are revolving around the shells outside the nucleus. In a nucleus, there are protons and neutrons. From the center of this nucleus till the circumference is the atomic radius. Outermost shell is called as valence shell. So let's see the effect of atomic radius in periods and groups. Keep in your mind this diagram. If you have the concept about the revolving electrons around the nucleus in the shells, then you clearly understand how atomic size or atomic radius increases or decreases in periods and groups. So keep this figure of atom in your mind. Let's see what is the effect of atomic size and atomic radius in groups and periods. This is the rough sketch of periodic table in which you can see the effect of the atomic radius in periods and groups. As we know, the horizontal rows are called as periods and vertical columns are called as groups. When you are moving in a period, you know that atomic number increase. Hydrogen having atomic number 1, helium having atomic number 2, lithium having atomic number 3, beryllium having 4, boron having atomic number 5, carbon having 6, nitrogen having 7, oxygen having 8, fluorine having 9, and neon having 10, and so on. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 onwards. So while the atomic number increases, which means the number of electrons are increasing because the number of protons and the number of electrons in an atom are equal. So for example, this is the atom of hydrogen having 1 electron in its valence shell, in its outermost shell. This is the atom of helium. This helium atom having 2 electrons in its outermost shell because its atomic number is 2, which means it having a 2 electrons. So in a period, here you can see number of electrons are increasing. If the number of electrons are increasing, then the attraction towards the nucleus will increase. Nucleus having some nuclear charge because of the protons. So that nuclear charge, that positive charge attracts the electrons that are outside the nucleus in the shells. So if there are more number of new electrons, which means there is more number of protons in the nucleus because number of electrons and number of protons are equal in a neutral atom. So when the number of protons are increasing in nucleus, they will apply more nuclear charge to the electrons. By applying more nuclear charge, more nuclear effect on the electrons, electrons come closer to the nucleus. Electrons will come closer to the nucleus. So atomic size of elements, of atoms, decreases along the period. Here you can see helium having little bit smaller size as compared to hydrogen because of the nuclear effect. Nucleus apply effect on the electrons, attracts the electrons towards the nucleus due to nuclear charge. In a second period, this was the first period, now see in a second period. In a lithium, there are 4 electrons In a lithium there are 3 electrons, 2 electrons in first shell and 1 electron in other shell. If you are going to see the structure of beryllium, beryllium having 4 electrons, 2 electrons in first shell and 2 electrons in second shell, L shell. So when the electrons are increasing, the nuclear effect will increase. These electrons will be attracted towards the nucleus. They feel the more nuclear effect than the atom which having less electrons. So that's why if you see in this period, atomic size will decrease. Because all these atoms of second period having only 2 shells. Neon also having 2 shells. If I'm drawing the structure of the neon, here you can see first shell having 2 electrons, neon having atomic number 10. First shell having 2 electrons and the second shell having 8 electrons. 1, 2, 3, 4, 5, 6, 7 and 8. So when the number of electrons are increasing in the outermost shell, due to this, effective nuclear charge will increase because the number of protons are increasing and they will attract these 10 electrons toward itself. Due to this, the size of this neon atom will decreases. The size of this neon atom will decrease because number of electrons are decreasing. Fluorine having 7 electrons, so having less nuclear charge as compared to neon. That's why fluorine having little bits bigger atomic size as compared to neon. So in a period, atomic radius will decrease. Lithium having higher atomic radius, bigger atomic size, and neon having smaller atomic radius or atomic size because the number of electrons
नहीं कल
in a
फ्राइडे
same
वाले दिन
shell
किसी को
are increasing. Clear?
मैं देती हूँ
So if you see in a group, this is a group. In a group, you can see this is a hydrogen having 1 shell, this is lithium having 2 shells, this is sodium having 3 shells, potassium having 4 shells, rubidium having 5 shells and cesium having 6 shells. Next is francium that having 7 shells. So you can see down the group the number of shells of the atoms are increasing. If the number of shells are increasing, then you can easily say this, the atomic radius will increase. For example, this is the atom of lithium. Lithium having 2 shells. So this is the radius. From center to the circumference, this is the radius. Having some radius. For example, this is the sodium atom. Sodium atom having 3 shells, 1, 2 and 3. So if the atom having more shells, having 3 shells instead of 2, then its atomic radius will be higher than the atom which having 2 shells. 1, 2, 3. Sodium having 3 shells, so the distance from the center to the circumference will increase. In a same way, if you see the structure of potassium, potassium having 4 shells. 1, 2, 3, 4. Potassium having 4 shells in which it contains electrons. So the atom which having 4 shells instead of 3 having a bigger atomic size or atomic radius as compared to the atom which having 3 shells. If you are increasing the number of shells, the atomic size will increase, the atomic radius will increase. That's why atomic radius down the group will increases and atomic radius along the period will decreases. So keep remember this, down the group atomic size or atomic radius increase and along the period atomic size atomic radius decreases due to same number of shells having more electrons increases in a group due to number of shells are increasing. Along the period we know atomic number increases, but the number of shells are not increasing. Down the group, we know that the number of electrons plus the number of shells are increasing. That's why elements who are down the group in a period having bigger atomic size as compared to the element that are along the period, those having atomic number increases, but there is no increase in the number of the shells. All the elements in a first period having one shell, all the elements in a second period having just two shells, all the elements in this third period having three shells, all the elements in fourth period having four shells, and all the elements in a fifth period having five shells. So keep remember that atomic radius, atomic size decreases along the period, increases down the group. Mostly this question is asked by the examiner in exams, that write down the trend of atomic size or atomic radius in periods or in groups. So you have to answer this, that along the period atomic radius decreases because number of shells are remain same, but the number of electrons are increasing, and atomic size increases down the group because the number of shells are increasing. This is our today's topic.